Okay, I wanted to take a little bit of a closer look about experimental probability and theoretical probability formulas, because those are the kind of the two that you need to know for calculating probability. So the probability of an event happening with experimental probability is the number of times that that event happened divided by the number of trials. So again, if we were talking about like dice, right, and we wanted to the probability of an even, then it's how many times we rolled an even divided by how many times we rolled. That's pretty much it. So A is just a generic, it's like an X variable, right? It's just a variable for whatever event you're talking about. So you'd say the probability of tails is the number of times you flip the tails out of the number of times you flip the coin. So that's kind of pretty basic. What we're really going to deal with more is this, because in your homework you're not going to do a bunch of experiments, right? Now they may give you some experimental data that you need to look at, or like a table or something or whatever, but most of the time we're going to be calculating theoretical probabilities, which is, you know, just thinking about how many different ways are there for things to happen. So this is the formula that says in your book, the probability of some event A happening is the number of outcomes in A divided by the number of outcomes in the sample space. Now this wording here on the top, I don't particularly like. I don't really find it intuitive or useful. If you like it, great. But what I kind of like to think about for this top line is the number of ways for A to happen, because sometimes there's more than one way. And in the dice example that I did, the dice experiment, there was more than one way to get an even, because you can get a 2, a 4, or a 6. So sometimes there's more than one way to get what you want. In the heads and tails example, there's only one way to get ahead, so that wasn't, you know, very good for that idea. So number of outcomes in A is the same idea as how many ways can you get A? How many ways or how many possibilities are there where you get what you want? So I'm going to say number of ways A event can occur. Okay? So let's do a couple practice ones here. So we want to find a theoretical probability, so we're doing this formula, for the following. Okay, pulling a jack from a deck of cards. Well, we have to know a little bit about cards, and if you don't, then this is going to be less, it's going to be a little harder. But in a regular deck of cards, there's 52 cards. Right? You got ace through 10, that's 10 cards, and then you got jack, queen, and king. So that's 13 of each, and then there's 4 different suits, or 4 different symbols. So you got diamonds, hearts, clubs, and spades. So you do 4 by 13, that gives you your 52. So if I want to know the probability of pulling a jack, this is what I do. Probability of getting a jack from my deck here is how many ways are there to pull a jack? Well, I could pull the jack of hearts, I could pull the jack of diamonds, I could pull the jack of clubs, or I could pull the jack of spades. So there's 4 different jacks in there that I could pull. So 4 different jacks, but how many different cards are there, right? So the sample space here is all the possibilities that I could get when I draw a card. So a trial would be drawing a card. The outcome I'm looking for, or the event that I'm looking for, is jack. And the sample space is all the things you could potentially get. So the sample space is all 52 cards. We want the number of outcomes in the sample space. Well, it's 52, right? There's 52 different cards that I can pull. All right, so that is my probability. Now I can simplify this, which we want to do with fractions, always. Simplify. Okay, you could also turn this into a decimal or a percent. Dividing by 13 is not going to come out super nice. But you could, let's do it real quick, just so we have it. So we got our fraction. We can divide it. And if we do that, we're going to get about, we're going to have to estimate here, but 0.077, or that's like about 7.7%. Okay, so that's the probability of pulling a jack. It's the number of ways that you can get a jack, or the number of ways that A can occur, the number of ways you can, get a jack, out of the number of total outcomes there are, which is 52 in this case. So that might be pretty intuitive for you, but the key here also is to like pull out the definitions, because when we talk about things that aren't cards, it might be a little bit harder. So sample space is a really important idea, and sample space is all the possible outcomes you could get. Okay, probability that your birthday lands on a weekend. So we're going to go probability, we'll kind of abbreviate here, of weekend. Okay, well again, we have to know some things, right? We have to know what are the possible different outcomes that we could get. Well, there's 7 different possibilities of your birthday falling on a day of the week, because there's only 7 days in a week. There's 7 different possibilities there. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That's your sample space. Your sample space is that list of days of the week. Now the number of outcomes in the sample space is 7. So sample space isn't usually a number. Sample space is usually a list. And then the number of outcomes in that space is a number. Okay, how many different ways are there to get a weekend? Or how many different ways are there for your birthday to land on a weekend? Well, assuming that the weekdays are Monday through Friday, weekend then would be Saturday and Sunday. So there's 2 different ways to have your birthday fall on a weekend, either a Saturday or a Sunday. Okay, so 2 7ths, and it's simplified. We could turn that into a decimal or a percent. So 2 divided by 7 is 0.285, sorry, 286 for rounding. Okay, which is about 28.6%-ish. Okay. All right. The last one here, the probability of pulling a non-white marble out of a bag of marbles containing 20 white marbles, 3 green marbles, and 1 red marble. So this is a little bit harder. So probability of, we're going to say not white. Okay. Well, how many ways are there for you to pull a non-white marble? Well, first of all, let's figure out how many marbles we have total, and then we'll figure out how many ways there is to pull a non-white marble. So this bag has 20 white marbles, 3 green marbles, and 1 red marble. That's 24 marbles total. So the sample space would be the list of all those possible outcomes, right? The sample space is white, 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 red, green, 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 right? Or however many you have. It's that list of different possible outcomes. You can pull this white marble, or this white marble, or this white marble, or this red marble, right? So how many different, assuming that each white marble is unique and different, how many different ways are there to pull a marble? There's 24 different marbles that you could potentially pull. And that's kind of confusing because you're like, well, pulling 1 white marble is not the same thing, is no different than pulling any other white marble. In this case, though, we want to count all of those individually because there's so many different white marbles in there. There's not just 1 white marble. There's a bunch of different ways we could pull a white marble. So if, let's say, we numbered all the marbles from 1 to 20, well, we could pull white 1, or we could pull white 20, or we could pull white 15, or white 17. Right? So there's still those 20 different ways we can pull a white marble. Okay? And then we can pull, of course, the green marbles or the red marbles. So how many ways can we pull a non-white marble? Well, I could pull 1 of the 3 green ones, or I could pull 1 of the red ones. Okay? So that's 4. There's 4 different ways I could do that. 4 different ways to pull a non-white marble out of all the different possible marbles I could pull out. So again, the sample space is just a list. It's a list of all those choices. White, 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 right? All those different choices. And we're assuming that it's equally likely for me to pull any of those. When we simplify here, we're going to get, this is 1/6, which I think is 0.16. Let me see. Oh, it's 0.167, or 16.7%. Okay, so important concepts here are you got to know how to find your sample space, and sample space is all your possible outcomes, and then you got to be able to find out the number of outcomes in that sample space, because that's what you need for the bottom. You also have to be able to think about or figure out how many different ways there are for the event to happen that you want to have happen, and sometimes there's only one. Like with a coin, there's only 1 way to get a heads. Sometimes there's more than 1, right? There's 4 ways to get this jack. There's 2 ways to get a weekend. There's 4 ways to get a non-white marble. So that that's just an example of how to use this. We'll do, you know, a little bit more detail in the next lesson or the next assignment probably, but that will probably be good for now. So tune in the next video. We're going to talk about another idea of finding out number of outcomes.